A very good morning to everyone. In this lecture, we are going to study about the Fick's law of diffusivity and how it's vary with the temperature. And we also know about Fick's law, which is very important in mass transfer operation. Uh, okay, let's start. What is a Fick's law? So basically, the Fick's law of diffusivity, which is describe the rate of the substance diffused from one region to another. Okay, so I have two region, one or two. If my substance is this, and I increase the temperature or the parameter, which is very okay. So if I change, okay, so the substance is transformed from one region to another region. But if I want to vary how much amount of how many liter, okay, so how much liter, how much kilogram of such substance, so this type of all the characteristics are vary by using of the fixed. I mean, if I said the H2SO4, I mean hydrochloric acid is diffused uh, x x meter square per second from this region to this region. Okay, but what is that x? How can I vary x? Okay, so by using of this fixed law, we can easily identify. Okay, so basically the fixed law of the diffusivity uh, describe the rate of the which a substance diffused from one region to another. It is the fundamental in understanding the mass transfer in gas, liquid and solid as well. Okay, so how much amount of substance transformed from one region to another region due to the increasing temperature, due to the change in the pressure, due to the change in the concentration. Okay, so that's why I already told you the parameter that can be effect. Okay, this type of all the parameter which is directly effect of the substance, so that with the substance is transferred from one region to another, so that by using of fixed law we can easily identify. So here for steady state diffusion, the fixed law said about a J is equal to D into dc by dx, while wherein the dc by dx is the concentration gradient, means how distance change, concentration change with respect to distance, which is called a concentration gradient. So here dc by dx, which is concentration gradient. D is the diffusion coefficient, which is commonly varied by meter square by second velocity. Okay, yeah, unit is same for velocity, but D is a diffusivity coefficient, and J is a diffusion plug, amount of the substance per unit area per unit time. Okay, so basically, so J is equal to dc by dx, while minus sign indicating that the concentration is in decreasing form. That means if I have a 100 ml of the H2SO4 and I give them heat, and I'll suddenly the real life example is day-to-day life example like petrol. If petrol are open in the environment, okay, we'll see after the 5 to 10 second, the okay, so petrol, after some time, the petrol is diffused in the air, so that the amount of the petrol is decrease. Okay, so our father told us, please keep it close. Okay, uh, but we want to know how much amount of petrol, how many liter of the petrol are diffused. So by using this fixed law, we are easily identify. So x is basically distance, a negative size indicating the diffusion occur in the direction of decreasing concentration. Okay. So some of the key observation like high temperature, in higher diffusivity, higher the temperature, so that the temperature and the diffusivity are proportional. That means if you increase the temperature, obviously the diffusivity of the substance is increased due to the motion. For here also already I mentioned molecular motion. Okay, and gas versus liquid versus solid. In gas, diffusivity increase rapidly with the temperature because of molecular corrosion because more frequent. Okay, in liquid, the effect is moderate because the intermolecular interaction, but in solid, diffusivity is low but increasing exponential with temperature due to the atomic vibration and defect. So that in gas, if you increase temperature, the diffusivity is higher than the liquid and then the solid, and liquid and solid remaining. Okay. Okay. Uh, the Fick's law show that the diffusion is strongly temperature dependent following exponential increase in temperature. Right. Okay. So significance of the Fick's law, that means क्या उसके महत्व है, क्या उसका use है. So predicting mass transfer, obviously if I want to make some machinery for mass transfer, okay. So obviously if I know how much of the substance transfer like petrol, okay. If I don't know petrol is diffused, if it is open, then how it is, are you able to understand? Okay, it's not in our side. Okay, if I don't know the petrol is diffused from one place to another place, so that it not good for me and also company as well. Okay, so for predicting mass transfer rate, okay, so obviously it is help to design the equipment. Okay, environmental application, as I mentioned here, are useful for in understanding how pollutant diffuse in soil or water. Biological system explain gas exchange in lungs and nutrient transport in tissues. I'll give you the example of the diffusion, like in a alveoli of the lungs, oxygen diffused from the alveolar air, high concentration into the blood, low concentration across the thin air. If we assume this data like a D diffusion coefficient is 2.4 10 raised to minus 5 centimeters square per second. Okay. Thickness of the membranes X is equal to 0.003 centimeter. Concentration difference delta C is 0.03 mole per liter. So using fixed law, we can easily calculate this, putting this value in this equation and then easily calculate, and we get this answer. Okay, minus 2, minus sign is indicating the concentration is decreasing from, so you can neglect this. Okay, but not, there is no issue. Okay, so mole upon centimeter square second, this value tell us how much oxygen diffusing per unit area per unit second, essential for medical and psychological study. Okay, so this what fixed law say about. And thank you for your patience, student. I hope you got it and understand well. Okay, and all the best for your examination. Thank you so much.